Suleiman. Oh, you can call me Chichi. That is a simple one. And also I have another name, which is Warda. So all of those are my names. I'm a data scientist by professional. I took my bachelor degree in telecommunication engineering. And currently, I have also completed master's in data science at University of Dar es Salaam. And currently, I'm working on a research which deals with virus suppression. So I'm generating a machine learning algorithm which will predict virus suppression for adolescents living with HIV/AIDS and which are on ART treatment. So today I wanted to speak with you about exploratory data analysis using Python. So I'm so much excited and hope we will learn more. So this session is a bit practical. So I hope that we will go on together. In case if there is anything that you didn't understand, maybe you just pop question in the chat and then I'll be answering the questions. So today, it's about data analysis by using Python. And then we have a lot of sections. We have the first one is to import data. And then we are going to analyze individual feature pattern using visualization. And then we are going to use descriptive statistical analysis. And then we are going to do basic of grouping. And then we are going to do correlation and causation. And the last thing will be ANOVA, which is analysis of variance. Okay. So our data set will be of that of a car. We are trying to predict which will be the car price by using machine learning algorithm. Okay, so that will be the aim. But before going to the machine learning algorithm, which we are not going to talk about it today, you have to explore your data, making them suitable for the algorithm to work. And then you, provided that you have a lot of features, so you have to choose which features will be suitable for the machine learning algorithm. So now the exploratory data analysis is a part where that you're going to explore your data, looking at your features, looking at the data type, looking at which features will be suitable for your prediction of the price of a car. Okay, so first of all, we are going to import libraries, and we have pandas and NumPy. For those who have a big knowledge in Python, before doing anything, first of all, you have to import libraries that will help you to do the calculation, or help you to do all of the manipulation that you're going to do in the notebook. So here that we have to import pandas. Pandas is it's a library that deals with DataFrame. Okay, so we assume that you're having an Excel file data, and then you want to import it into Pandas so that it can have, let's say, in a form of a table. Okay, a table form where you have columns and rows. So Pandas is one of the libraries that will make that Excel file or CSV file data to be converted into table form. We call them DataFrame. Okay, and then we are having import NumPy as NP. NumPy is a library that has also have manipulation in the DataFrame. Some of the manipulations are not in Pandas, some of them are in NumPy. So we have to import both of them if you want to have overall manipulation. Okay. So apart from that, we're going to have our data sets. The data set is for this time, it is in this URL. Okay. This is the one that was provided by in IBM classes. So this is the data set of a car features. Okay, so I'm going to name my file as path. So it will be path HTTP. Just input the data frame there, and then I'm going to read the file. Okay, So it will be PD. Now this is the pandas.read CSV. The file originally was a CSV file. So if it is original Excel file, it will be read_Excel. Okay. So if it's a GeoJSON file, it will be PD.read _GeoJSON. So here is where you're going to put the file format of your data. Okay, so this is the df equals to pd.read CSV path is the name that I've given this URL, and then df.head. Okay, so let's say I'm going to put these. Let me copy these. Okay, and then have them in a new cell. Okay, so that you can understand March, because there are lots of columns here. I mean, a lot of lines. So it will be easy for you. It won't be easy for you to understand much. Okay, so I'm going to run this. If you want to run, you're going just this is the button, run. So for now, all of the data set within this URL is in the path. Okay, and I'm going to run another line, which is pd.read CSV. Now I'm converting now the CSV file to be in a DataFrame file, and I'm naming this DataFrame to be df. Okay, so I'm going to run this, and then after running this, let's wait. Okay, now it has run, and then df.head brackets. Now I want to view my file. Head is you're taking the first 5 rows of your data set. If you're not going to put head, let's say this head, let's say you have 8 rows. If you want 8 rows to be converted, you put 8. If you have 5, you put 5. If you want to view 7, there's a lot of rows, so you just choose what you want to view so that you can see if you have your data set there. Okay, so I'll run df.head, then it will bring to me the first 5 rows. So this is my data. Hello.
Please, we can see your screen.
You can't see my screen?
Yes, we can see the exploratory data analysis and desktop and some other questions, but the down is black. That thing is black and we can see it.
Okay, now yes, can you see?
Now we can see.
Okay,
yes.
Okay, thank you.
Excellent.
Sorry,
guys.
You
have to start from the day one.
Okay.
You are very technical, so yeah.
Sorry, guys, I didn't know if you are in Sigmas. Oh, so there are some messages here in the chat.
We've been typing in the chat.
Okay.
Yes. Okay. It shows you are a geek. You're a geek.
Okay. Now, so let's start again. Hey, everyone. Okay. First of all, I was saying that today we are going to speak about exploratory data analysis, and in here we are going to explore data of a car features, so that at the end of the time we can predict the car price, which I think it won't be okay. So you import libraries. So you first import pandas, and then you import NumPy. I hope now you can see my screen. Okay, after there, I say that the URL, this is the URL where the data sets are. So I name this URL as path so that I can use it in my manipulation. So path equals to this and this, okay? And then after there, this is the URL where the dataset is. And then there is df equals to pd.read_csv. So read, now I'm telling now, please go and read this file. It is in the format of CSV, okay? And the name of that file is path, okay? So after running this, I run this and then I run this again, okay? So now all the file, let's wait for it to run. Okay, and then while it's proceed, so then we go to df.head. So this you want to see the very first rows of your data set so that you can just have an overview of how the data frame looks like, or how your data set looks like. Okay, so I'm going to run this again, and so this is how my data frame look like. Okay, so I'm having this symboling, I have normalized losses, I have aspiration, I have number of doors, I'm having body style. Okay, so this is the body style of a car, number of doors of a car, if it has 2 cars or 4 cars, is it a standard one? Okay, and then we have drive wheels, if it's the forward or reverse one. Okay, and then we have the engine location. Okay, we have the wheelbase, we have the length, we have the compression ratio of the tile, we have the horsepower. Okay, so this is the pressure staffs, we have the peak, RPM, and then we have the city miles per gallon. Okay, so this is the miles per gallon on how much fuel that this car can take, and then we have the highway, the price, and others. Okay, so this is how the data set looks like, and then we want to use these features in order to have to predict the price of a car. Okay, so apart from that, I was saying that if you want to, let's say this is .head, you get the first 5 rows. Okay, if you put, let's say, .tail, okay, .tail, you're going to have the last one. Okay, so you see I'm having 200 rows, so these are the last ones. If you want the first 50 rows, you're going to put, the last 50 rows are going to put these. Okay, so you're going to have the last 50 rows. If I want the first, so by default, if you don't put anything, you just put the first 5 rows. So I'm not going to put anything, and then I'm having the first 5 rows. Okay, I hope we're good there. And then now we want to analyze individual features now of the car so that we can see which one can help us to predict the car price. Okay, so in the meantime, we're going to have a lot of visualization in order to analyze this. So we want to install Seaborn. Seaborn is a library that have visualization packages. So we are going to have some of the visualization here. So Seaborn is the one that have some visualization together with Matplotlib. So Seaborn have some graphs, okay, and Matplotlib have maps, have also some graphs. So it's okay if you can import both of them. So have we installed Seaborn, and I've also installed Matplotlib. So import matplotlib.pyplot. These are just names. They're just fancy names. They're simple ones, okay? Don't get scared of this, okay? Now we want to do the visualization method, okay? So before going to the visualization of individual variables, it's very important for you guys, for everyone to understand what type of variables that you're dealing with. So this one will help you to find the right visualization methods to deal. So first of all, I'm going to go through the columns, each column, to know that each column is of which data type, okay? So I'm going to list the data types for each column, okay? So df.dtypes, it's as we say a key value or a keyword to determine the data type. Okay, so there's say D types. Okay, so df.dtype, then now I call it to print the D types of these data frame columns. Okay, so I'm having the symboling, I'm having the normalized losses. So these are the columns, and these are the data types. Okay, so I'm having integer 64. Integers are these numbers. When you see objects are a mixture of string and integer. I hope you somehow know. Strings are just words. The normal words, those are called string, and integer, these are numbers 1, 2, 3, 4. Okay, and you're having you see there is float 64. So float 64, it's more of some decimal. Okay, integers that have decimal points like 10, 10.23, 10.4, 10. Yeah, those are floats. So these are our data types. Okay, so for example, you want to know the data type of a certain column here. Let's say I pick this peak RPM. Okay, the peak revolution per mile. So here I'm gonna just run these. Okay, it will tell me the data type is float 64. Can anyone tell me which data type do you want to know of each column so that we can find here? In the chat, please. Like you didn't put the D types, this one. So anyone who is interested in any column here, so that we can see if this one will work out. Because this is the initial stages. You have to know the types of the data type of your columns. Anyone? Okay, guess. Okay, Isaac said he wants to know that of a guess. We know it is integer 64 here after writing, but let's say df to call a column in a data frame in Python, you have to call the name of the data frame, which is df, and then you put the square brackets, and then you put the name of that column. So the name of that column is guess. Okay, so I'm going to do the D type so that I can have to see what type. So the D type of guess is integer 64, you see? All right. So after there, now let's go, we can calculate correlation. Correlation, this is a statistical thing. It's more of if you want to know the statistical relationship of one feature or one variable to another. So if they're highly correlated, we mean that these features have a lot of similarities together. So in the model development, let's say you're just creating a machine learning algorithm and you have two features which have they are highly correlated to each other. It means that you can just choose one feature for the model development, okay, because they're highly correlated. And if they are not highly correlated, you see that you can just choose two of them, and then they can also have an impact in the prediction of y. Okay, assume that we're having y equals to x plus y, and I mean z equals to x plus y, and my z is my output, and then I'm having feature x and feature y. So feature x and feature y, if they're highly correlated, we mean that you can just choose one. There is no need of using both of them because both of them have equal contribution to the z. Okay, but it's opposite now when I'm saying that my output is z and then x plus y. Okay, so z equals to x plus y. If z my output and x my input are highly correlated, it means that these features, I mean the x feature, contribute much to the prediction of z, and I'm going to choose x feature. I hope you get me there. Okay, so there is between the features, you're finding correlation between the features, and you're finding correlation between the output y of your prediction model and the input. Okay, so it is the vice versa. When you think of the features, what feature to put in the machine learning algorithm, the ones that are highly correlated to each other means that they have the same contribution to z output. Okay, so you can just pick one instead of having both of the features. But if you are having the X and Y and your Z output, now if you're comparing the correlation between Z and my X there, if the correlation is high, mean that X is a good feature for model development or model prediction. Okay, I hope you have understood me there. So df.core, so correlation, the keyword of correlation here is df.core and then open brackets. And then after here, I'm going to run this. So now I'm having the correlation between each one. So you see there are rows here and there are columns. Columns are symboling normalized losses, all the features of the car. And I'm also having all the features here in the row. So when, let's say I'm looking on the correlation between length, okay? And then between length and wheelbase. Okay, so the correlation between length and wheelbase here, it is 0.876024. You see, so these features, they're almost 80% correlated, okay? You see? Let's say, so we say that these are highly correlated. But when I take the feature of wheelbase and normalized losses, the correlation is negative 0.05. So they are low correlated to each other, okay, because it is almost negative 0 point something, okay? And when you check normalized losses and let's say width, you get 0.086. So this means the correlation is 0.8. So they are not much related, okay? But so between, let's say you are in a point that you want to choose width feature. No. I'm looking for those who are highly correlated. Almost 90. I'm seeing the 84, 80, 80, 80, 80, 80, 80, 88. I'm not seeing much. Let's say this one of 87. So whenever you're called to, let's say you have to choose between wheelbase feature and length feature, whether to put them both in the model or to let's say choose one. So it's better to choose one because they're highly correlated. So they're kinda the same thing to the Y output. So now my Y output, remember we are predicting the car price. So the output will be price, okay? This price column will be the output. So I'm checking on the correlation of this price with other features, okay? With other column. Let's say price, I'm having this price in the price column, there is 0.75. So it's almost 75%. Oh, there is this 87, okay? You see there is this 87%. So let's go and find which column is this, which feature is this, which feature is this. So it is engine size, which means that there is a high correlation between engine size and price. So engine size contributes much to the prediction of the price of a car. And I think this is true, okay? And whenever you want to buy a car, someone will say, will ask like, what is the engine size, okay? Is it a big engine? If the one that has it's a car with a big engine, means that the price will be high. And if it's one has a lower engine, small engine, not that big, means that you will just choose the one with the lower one. I mean, the one with the higher engine, the one with the engine size with the lower engine size will have a low price compared to the one with a bigger engine size. So here is where now you can see, like in the early beginning, you can see, okay, so these are the features that I'm going to use, and these are the features that I'm not going to use. For example, I'm having negative 0. In the price here, I'm having negative 0.08. Okay, so this one, so it is almost 0.8%, okay, 0.8%. So symboling, it's not one of the things that contribute to the price of a car. So you can see that you cannot put it, you can just not put it in the features to predict the price of a car because they're not safe. not of that importance because of its correlation percentage, okay? All right, so now let's go and find the correlation between each of the features, okay? So let's find the correlation between bore, stroke, compression ratio, and horsepower. So these ones, let me run it again. So I'm having the bore, the stroke, compression ratio, and horsepower. So for here, this one is a bigger table. You see I've put all the columns, but this one, you just choose the one that you need, okay, to look out. So you can see that between stroke and compression ratio, it is 18% correlation, okay? And you see between bore and horsepower, it's 56% correlation. So you can choose, you can see that these are not highly much correlated. So you can just put all of these in the model prediction for price, okay? Because they're not much correlated, okay? So here you can just choose any and just check any and find the correlation between. Okay, there is also this, because we're having data type of, we're having columns of features or variables with different data types. So we're having those of a continuous numerical variables, okay? So these are variables that may contain any value within some range, okay? So the continuous numerical variable can have type of integer 64 or float 64, the one with integers, okay? So the great way to visualize these variables is by using scatter plots, which are these scatter plots are the one that is fitted with a line. We call a linear line, okay? So we can do this by using a reg plot. So this reg plot it's more of a keyword in order if you want to let's say to plot a scatter plot, you have to use a reg plot, okay? It's called a regression plot, okay? Yeah, so first of all, I think I've forgotten to tell you first that the aim here is to have we're going to create a model, or we're going to develop a model for prediction of a car price, okay? So if you want to create a model for prediction of a car price, we need to have several features, as I said before. But there are several machine learning algorithm model, which I think this is a part of the other parts. So one of them is linear, okay? We have regression models, which is linear. We have multilinear, we have there are others, there are random forest algorithm and others. There are a lot of machine learning algorithms. You can just go there and Google. So today here we focus on linear, okay, linear model, okay. So that's why we want to check these, if these features are fit for the prediction of a price using linear, okay. Yeah, so let's find the scatter plot, let's say for engine size and price Y. So here I'm looking, apart for the correlation there, for you to know, here is another technique for you to know if this feature is, there is a linear relationship between this feature and the Y output that I want to predict, okay? So the engine size, so we put the, I hope you remember this is Seaborn. I remember this, you remember this is Seaborn. So Seaborn.regplot, okay? And the variable that I'm going to put is X, which is engine size, and then the output variable is price, okay? And the data that I'm going to put is DF, okay? And this is the Y limit that I'm limiting my Y value because I'm having the X and Y, so the Y value to have 0, to start with 0 and then continue with the other. So that's why it started with 0 here. Okay. So this is the scatter plot. So if you see here, you see the engine size and price. As you remember, the engine size there has a correlation of almost 87% or 85. Okay. So means they're highly correlated and means they have a linear relationship between each other. Okay, if things are highly correlated, it means they have a highly linear relationship between each other. So as you can see here, the line fitted just is almost a perfect linear line. So let's choose another one. Let's choose that of a guess. Let's choose that of a guess and see what would be the line. You see now, if you put X as a feature now, they are not highly, you see there are not linear relation between a guess and the price, you see? So I think this guess won't be a nice or a good feature for the model, for the prediction of price of a car, okay? Let's choose another features. Let's say, can you name any feature that you want to put and see? Anyone can write in the chat between these features here, which one you want us to look at. I'm waiting. Guys, am I alone? Okay. Okay. Let me choose of something else or someone. Diesel. Okay, thank you. So let's check on diesel. So Python is case sensitive, so you have to know if diesel started with a D, or with a capital D, or a small letter D. So I check it out. It's small letter D. Okay. So diesel. You see, not much of a linear relationship between them. So diesel won't be a feature to use in order for car price prediction. Okay, let's choose, I don't know, horsepower. Let's check on horsepower. Is horsepower yeah, horsepower has a linear relationship. So we take down that we have horsepower and then we had the engine size. So we got two features now that have linear relationship with our price. Okay. Okay. So we can just go and do and try as many features that we have. So this one created the highway. Okay, a highway MPG with price. As you see, there is linear relationship, but it's a negative relationship. As you can see, the line it's slanted this way and not this way. So you see it's a negative linear relationship. If you remember the linear equation, y equals to mx plus c. So you can see the slope now m, it's negative. Okay, so that's why it's slanted this way. So we see that this indicates an inverse relationship between these two and could potentially be a good predictor of price. Okay, so whenever you see negative, does not mean that this is a bad predictor. It's more of when what you have to make sure now is not only let's say you have the correlation of negative. Whenever you see negative, you say, no, this is not a good predictor. No, okay. You can have negative and it will be a good predictor. Which you have to check out is the percentage of correlation, and also if there is a linearity relationship between that predictor and the price and the prediction that you want to make. Okay, so highway is also a good predictor, okay, because it has a negative relationship. In order to to make sure that it's not only the scatter plots that give us these answers. It is also the correlation. It's 70%. You see, it's negative 70. So it is a good predictor. When you see the slope is negative, means that whenever highway is low, highway miles per gallon is low, price is high. And whenever highway mile per gallon is high, and then the price of the car will be low. So that is what the interpretation of the negative, okay? All right, so let's see on the features that have a weak linear relationship between the feature and the price. Okay, so this one is the one. You see there is no linear relationship, it's almost straight. So peak RPM, we cannot use it. It seems like it's not a good predictor of the price, okay? Also, let's check on the, you can also confirm it by using correlation. So you can have the numbers that shows the level of prediction. Okay. So here is just a question, like if you can find the correlation between X equals to stroke, to find the correlation between stroke and price, okay? So you can just write DF. I want to check on the stroke. I want also to check on the price. Okay, dot score. Okay, so you see there is 0.8% correlation between stroke and the price. Okay, so it is not highly correlated. Okay, you can also have the to find the linear relationship between these two for the same as this one, if you want to confirm. So you can have, let's say, a Seaborn, the drag plot. Okay. So what am I inputting here? So I'm having my variable X, which is what? Which is stroke. Okay. I'm having also my variable Y, which is the price now I want to predict. Right. And what is my data? My data is DF. Okay. So after having this, so this is the scatter plot. Okay, so this is the scatter plot, and you can see there is no good match of a linear relationship between these two. Okay, so we are done with continuous numerical values. You remember the integer and the float. Okay, so now we are going for categorical variables, the one with objects and blah, blah, blah. Okay, so here in the is the interesting part, because the categorical variables can have the object type, which is words and the string and the numbers, and also can have integers type. Okay, so in order to visualize these categorical plots, we normally use box plots. Okay, so the first one was regression plots for scatter plots, and now we're going to box plot. Okay, so the categorical one, if you can remember here, I'm looking for df.head. Okay, the categorical one are the one that the drive wheels. You see, you have the forward one, okay, the reverse one, okay. So these are the categorical. You have number of doors, there are 2, 4, these are categorical. You have engine location, up front, let's say there is back, okay, or sideways, any, okay. So these are the categorical, and this one are the float one, the wheelbase, these are floats. Compression ratio, these are floats. Okay, so we're dealing with the categorical one, this one, the engine location, the drive wheels that have several categories. Okay, So we go to the categorical ones. Okay, so the formula is the same, or the syntax is the same. We take cbond.box plot, and then you put the feature, the X value, which is the body style. Okay, there is body style, there is also wheelbase, I remember. If you remember the categorical ones. The categorical ones, there is, no, wheelbase is not. There is drive wheels and engine location and body style. So these are there, and there is also horsepower bind. Okay, so these are. All right, so let's run this. So here we see this is the body style. There is one which is convertible. Okay, there is one that is hatchback. There is sedan body style. There is wagon. There is hardtop. Okay, so these different body style categories have a significant overlap, and so body style will not be a good predictor of this price, because as you can see, we have convertible here. It started at between 10,000 and 15, okay? And you have this hatchback here. It started at 5,000 and 20,000. So there is an overlap between the convertible and this hatchback, okay? And there is also sedan style, which is started at a little higher at 5,000, maybe it's 6,000, up to, let's say, 34, okay? And there is this wagon here that started at a little bit higher. I think this is 7,000, and it ended at 20,000. And this hardtop, it started at 8 or 7, and then ended at 45,000. So when you see this, these are categorical variables, and they overlap in the box plot. What you say that is that these ones have overlapped. So if they have overlap between each other, the categorical feature, it's not a good predictor of price, because the overlapping is the same as, remember, the correlation, the ones that have the feature that have highly correlation between the other, you remember? Yes, so the feature that have highly correlation between the other are not the good features between each other. So if you see the distribution of the body style together with the price have overlapped each other, it means this one is not a good predictor of the price, okay? The dots here that you see, these are the outliers. So one of the data have values that is not in a normal range compared with the other. So this is the meaning of these dots. So we go to another feature, categorical feature, and this is engine location, okay? So we put X is engine location, and my predictor Y is price, and the data is DataFrame. So you see here we have front, and then we have rear, okay? So here you see the distribution now of the price between these two engine location categories, then they have not overlapped, meaning that the front one started at 5,000 and it's ended up to nearly 27 or 28, okay? And then the other one, the rear one, started at 30, almost approximately to 32, okay, 32, and it's ended up at almost 37. So you see they have not overlapped between each other in the price prediction. So this means that this feature of engine location is a good predictor of price, because the distribution of the data together with the price has not overlapped each other. So meaning that it's a good predictor, okay? So let's examine other features. So this one is drive wheels, okay? So the drive wheels here, we have the forward, the reverse one, okay? and the other. There is an overlap, but not much overlap. So this one is a bit tricky. You have to know, you have to check on the distribution of these features, because the first time when you see this, you might think that these ones are they have overlap between each other. Okay, you can see that the drive wheels and this body style, they have, the body style have been overlapped much compared to the drive wheels. Okay, so they have overlapped a bit. Okay, they have overlapped, but it's a bit, because between this one, between the blue one and the orange one, this one started at, let's say, 7,000 and it ended at 37,000, and the forward one started at 5,000. No, this one started at a bit higher. Okay, and this one started at exactly 5,000. So this one is 7,000, this is 5,000, and it's ended at 15. This one ended at 37. And this one started at, let's say, 8,000 and ended up to 11,000. So if you see the distribution, they have not overlapped much compared to this one. This one you got the one that have exactly, they have started the same, like hatchback and sedan style in the body style. You see, they have started exactly at the same time. I mean, at the same, and they have the price, the same price almost. So you see that they have overlapped. So if you were to choose, this one will be number one. This will be our number one categorical variable to choose. This is engine location. And then the number two will be drive wheels. And then the body style will be the last one, okay? Yes. So apart from the categorical, we have descriptive data. So we're going to, let's say, to have descriptive statistical analysis for all our continuous variables. And here what we do, we check on the mean, we check on the standard deviation, we check on the interquartile range, we check on the minimum value, we check on a lot of statistical type things, okay? So in order to describe, to have a descriptive statistical analysis, what we do, we call a keyword known as describe, okay? So this describe will give you the statistical analysis of your data sets, okay? So here you have the features, and then you have their standard deviation, their minimum, their maximum. You got even the interquartile range, the interquartile range, the interquartile, the quarter one, the half one, and the 75% quarter range. So all of these shows the statistical distribution of your feature, and you can select features from the statistical point of view. For example, I'm having my price here. Remember the price, the one that we're trying to predict, okay? So its count is, let's say, 201, okay? 201. So I'm having, my data sets have 201 data set in price, okay? And all of them have been full. You see all the symbol. I don't have null values, because you might see here, the good point of this is that sometimes you want to predict price, okay? And you have seen, let's say, body style, I mean, not body style, the one that we use, the other one, the engine location, okay? The engine location is one of them. Now this for continuous variable, the engine location is categorical, so you're not going to check on it in the descriptive analysis. So let's check on the one that have highly correlation, the horsepower. Yeah, the horsepower. Okay, you have count here. So horsepower is one of the features that have described a very good linear relationship with the price. But the bad part may become that the count of horsepower is, let's say, 20. You have 20 data sets that have horsepower, and your predictor is 200. Okay, so you can see that horsepower is a good, yes, it's a good predictor, but you cannot going to use it in the model development when you cannot use it as a predictor because it has few variables. So this is one of the things that you have to check in order to see which one of the feature you're going to use in the predictor, in the prediction of the price. Okay, as you can see here in the describe, you didn't, only the features that appear are the ones that are continuous, the integer and the float. The one with categorical don't appear here. The objects don't appear here in the descriptive because the descriptive just take only integers. So if you want to have a descriptive analysis for even those with categories, the body cell and stuff, you have to include object here. So this one will help you to have a descriptive analysis of the categorical variables. So here you can see number of doors, you can see the count of number of doors, you can see the frequency, you can see the unique values, you can see number of doors have 2 unique values. And if you remember, it is 2 number of doors and 4 number of doors and nothing in between, okay? Body style, there were 5 body styles. So unique means the unique name, the unique words that appear in the categorical variable, okay? Yeah. Apart from having this unique, there is also another way of knowing the unique value that a certain feature have, and also you can also know how many are there. For example, you don't know, let's say the drive wheels are how much. You want to go through and see, like in the drive wheels there are how many categories, and each category has how many numbers in the data set. So here is the code where it's drive wheels.value counts, and then you know each one of it and its count. So you know the Ford are 8, the reverse one are 75, and so on. Okay, and you can also change this into DataFrame if you want to put them, because this is just a list, it's not in the table form, the value.count. So you can change the value.counts to frame. This is where now you can change the list value of the drive wheels into a DataFrame. Okay. Also, so now what we have to do now, we want to change. Okay. You see now you have the drive wheels here. You see now when you say the value.count, it just counted the category and the type and the head. Now the title of the column is drive wheels. You can just change the title of the column and name it to value.count. So this is the code where drive wheels.count, you rename the column from drive wheels, you rename the column to value.count. So this is just a way of renaming columns. Okay. This mainly is in the initial stages of understanding Python and pandas. Okay. You can also change the index. Index, it's you can see here the index now does not have name. Okay, it's just blank. So you can just change the index name to drive wheels. Okay, so drive wheels count.index.name. This is the drive wheels. So the drive wheels, just a proper arrangement of your analysis. Okay, and you can do this for engine location the same. Okay, you find the engine location dot value dot count to frame, and then you rename the columns from engine location to value counts, and then the in place equals to true. This means that you want to make, these are the changes that you're putting in your data frame. So you're telling this, make this as a permanent change. So that's the meaning of in place equals to true. So we have put this to be a permanent change. Okay. If you rename and you don't put in place equals to true, when you restart again your notebook and run again, it won't, the rename one won't appear. The new name that you have assigned, it won't appear. So in place equals to true is very important when you want to rename your columns and make permanent change. Okay. We continue with exploring. Okay. Exploring other features. So another feature is fuel system. So we want to check this fuel system. Can someone tell me the fuel system, categorical value and price? Is fuel system a good predictor of price or not? For this box plot output, can anyone tell me that fuel system is a good predictor or not, and why? If you're following up. Anyone, you can just, it's okay, you can just unmute your mic and speak. Hello. Hello. Okay, let's proceed. Maybe someone will answer it later. All right, so this is the fuel system and the engine size. I think we did this already. There is also horsepower bind. Okay, there is also horsepower bind. So you can see the distribution of the horsepower bind categories with price. Okay. All right. There is also a way of grouping things for these categorical variables that have several categories. You can have a way of grouping, and you can also group, let's say one feature. You have like 2 features or 3 features. You can group the 2 features and then see how does this feature appear, like say find the statistical analysis of the features. So basic of grouping, we have the group by method, which the one that groups data by different categories, and the data is grouped based on one or several variables, and the analysis is performed on the individual groups, as I said. So for example, let's group the variable drive wheels and say that the 3 different categories of drive wheels. So drive wheels, remember drive wheels have these, okay? So if you want to know on the average which type of drive wheel is most valuable, we can group drive wheels and then average them. Okay, we can select column drive wheels, body style and price, and then assign them to group 1. So this is the group 1 where we took the drive wheels, the body style and price, and then we can calculate the average price for each of the different categories. So this is how we can find. So okay, so we have the drive wheels, and then we see now, okay, forward one has a bigger price compared to the reverse one, is it? Yeah, has a bigger, I mean, compared to the rear one, has a bigger value. Okay. No, the rear one has a bigger value. Like, yeah, the rear one has a bigger value. It's 19. 19,000 and this one has 10. Okay, so from our data, it seems that the rear wheel drive vehicles are on average the most expensive, while the four wheel and front wheel are approximately the same in price. And I think this, even the Lamborghini's one, yeah, they're the one with the rear wheel drive. So the rear wheel drive are the most expensive one compared to the four wheel and compared to the front wheel drive. So you can also group with multiple variables, okay? You can group them, let's say drive wheels and body style are the same, and just check on the price of the body style. So the four wheel drive with the hatchback style has 7,000 price, okay? The four wheel with the sedan style is 12,000, okay? So which one is the most expensive here? Let's see which one is the most expensive. The 12,000 or the 23, the 24? The 24 one, yeah, the 24 is the 24 one is most expensive. So the rear wheel with the hard top body style, this is the most expensive car price compared to the other. So you can see here, we're having different, you can group and find the price of each, okay? You can group drive wheel and price and find the price of drive wheel. You can group, let's say, drive wheel and body style and see a drive wheel corresponding to a certain body style, what would be the price. So this is what we call exploratory. You explore your features before going to the prediction of the model, of the price, let's say, or whatever that you want to predict, because this data set is just an example. You can have any data sets and you can predict anything that you want to predict. And these are the procedures. So the data sets of a car features is just an example. You can have a lot, okay? Yeah. Another one. Okay. There is this one. We have, let's say, the price, okay, and then you have the body style and the drive wheels, and then you can have the price. When we were doing this, we saw that there are some of the things have null values, okay, like some of the type of the body style don't have a corresponding price. So you see there is null here. Null means 0, okay? If you see null means 0. So you can fill null with 0 so that you can do manipulation, okay? So we fill missing value with 0 so that we can have other manipulation. So this is this is the code whereby you can fill null. Fill null means filling the non thing to 0, or you can fill with anything, okay? I can just fill here before, let's say if I don't want 0, I want 1. So fill null with 1. Okay, so whenever there was null, I put a 1. Fill null, let's say, it depends with what you want. Fill null with 10. Okay. Okay. Fill null with 2. It doesn't. Do you know why? Because these are null values, they don't have then place equals to true here. Okay. Let me put, let's say, let me run this again. Then let me run this. I'm having nulls. Okay. Okay, I think there was internet issues because this one needs to be updated now and then. Okay, so grouped fill now equals to 0. Okay, so the one we had with now it's filled with 0. So this will help you in the model building. Okay, it also help you in some statistical analysis that we're going to do them at the end. Okay. Another thing, this is just a way, like if you want to find the mean or average of the groups that we have grouped by the body style and the four wheel and rear wheel type. Okay, so this is just a way of having the mean. If you want to find the mean, like in average, the one with convertible style, which is the price. You see the price is 21. In average, the price for a body style hard top, which how much is it? It's 24. So you know the normal range, and then whenever you create a model, and then let's say your model overshoot among the range, now you can see, okay, something is wrong, because model have to be tested. We create them, and then at the end of the time you have to test them so that you can know if they perform well. Okay, before putting it into the field, first of all, after just developing, you test them. So here I'll just help you to see that. Another thing of taking these categorical variables or even the continuous variables is by using heat map. Okay, so this one is used for grouped results. For the one that we have grouped, the body style and the wheelbase and the drive wheel, sorry, the body style and the drive wheel. We have a heat map whereby the concentration of the color indicates which one to do to visualize how the price, let's say, is related to the categorical type. Okay, so this is the code. This is a P color, and then this is the heat map, and then this is the color coding RDBU. These are the color coding of the normal colors, that there is red, blue, and other colors. Okay, so you can see here. So the heat map plots the target variable price proportional to color with respect to the variables drive wheel and body style in the vertical and horizontal axis respectively. So this allows us to visualize how the price is related to the drive wheel and body style. Okay, so the default labels convey this 0 to 10 convey no useful information at all. So we are going to change this into the 2.52 has no useful to us. So we're going to change it and put it in a way that we can interpret. Okay, the 1, 2, 3, this is the car price, 5,000, 10,000, this is the car price, but the one in X and Y, 1 and 2, 3 are not what we want, because we cannot understand this. So we have to change this into the way that we want to understand. So figure, and then these are the label names. So we put the label names, the row label and the column labels to be the one that we group there at the beginning, and then move the ticks and labels to the center. Okay, because they are not in the center. Most of them were at the end. So you move them into the center, and then you insert labels. Okay, you have the label name, but you didn't insert them. So you insert them, and then apply rotation. Rotation means how will this be aligned? Okay, will this be aligned and at an angle 10, 90 or 180 or 270 or 360. So this is just an alignment of the labels. So by seeing this, you can know that the convertible one, the convertible body shape together with the 4-wheel drive the price ranges from 0 to 5,000. Whenever you see this color, you see that the price is 10,000. So the wagon and the sedan, with the four-wheel wagon with the front wheel drive, its price ranges from this, okay, from above, let's say from 7,000 to almost 17,000. Okay, yeah. So this is how you name. I mean, you read the map. Okay, the heat map. So visualization is very important in data science, and Python visualization provide great freedom. So we'll go more in depth in a separate Python visualization course. I mean, let's say if we have different courses for Python visualization next year, or machine learning algorithm next year, we are going to explore much and do much of this. So the main question that we want to answer here is, what are the main characteristics which have the most impact on the car price? Okay, so to get a better measure of the important characteristic, we'll look at important features or important variable. We'll look at the correlation of these variables to the car price. And when you say correlation, we mean how is the car price dependent on this variable? And I think we did correlation in the first, but we didn't do causation. Correlation is the measure, as I said before, measure of the extent of interdependence between variables. And causation is the relation between cause and effect between the two variables. So it's very important to know the difference of this, because the correlation between two features does not mean the causation of the two features. So determining the correlation is more simpler. It's much simpler than determining the causation. So causation requires independent experimentation. So in correlation here, we have what we call Pearson correlation. So apart from the correlation that we're doing, we have other features called Pearson correlation. So the Pearson correlation measures the linear dependence between the two variables, X and Y. Now, these are the things that we have to put them in mind. If the resulting correlation or coefficient of the correlation is 1, we say that this is a total positive linear correlation between the two variables. If the coefficient is 0, okay, we say that there is no linear correlation between these two, and most likely do not affect each other, okay? And if correlation is -1, okay, there is a total negative linear correlation. So the Pearson correlation, is the default method of the function correlation. And like before, we can calculate Pearson correlation of the integer 64 or float 64, the integer ones, okay? So you remember this, df.core, and pass through this. So in Pearson, we have something else which is called p-value. So p-value is a probability that the correlation between these two variables is statistically significant. This is very important. They're not only significant, but statistically. So normally we choose a significant level of 0.05, which means that if we had 95% confident that the correlation between the variable is significant, we go with it, okay? So if we have a p-value of less than 0.01, we say that there is a strong evidence that the correlation is significant. If the p-value is less than 0.05, there is a moderate evidence that the correlation is significant. If the p-value is greater than 0.1, we say that there is a weak evidence that the correlation is significant. And if the p-value is greater than 0.1, there is no evidence that the correlation is significant. So these are the things that we have to go with them in mind, so that we can know that if whenever we look on the correlation, which one which one of the features is statistic, if we'll be confident to say that feature X with the variable price are statistically significant, okay? Okay. So in order to import the Pearson and the statistic of that Pearson coefficient, we have to import from SciPy. There is a library called SciPy. So from SciPy, you import stats, means statistics, okay? So now let's calculate between the features. Let's calculate wheelbase and the price. Let's see if we'll be statistically confident that these two features are correlated, okay? So doing that, you have to call the Pearson coefficient and then call the p-value, and then this will be equal to statistic.pearson, okay? And then we put the wheelbase and the price, okay? And now we tell that print, so print the Pearson correlation is this one, and then with the v and the p-value of this one, okay? All right. I think for those who are familiar with statistics, this is very common in statistics. Okay. So we're going to run this, and then it says the Pearson correlation is 0.5 with its p-value 8. Okay. So can any now we have seen the answer. I wanted to ask you, are you statistically confident? What the meaning of this? If you see p-value is 8 blah 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 times 10 power negative 20, do we are we confident that there is a correlation, or we are not confident? Anyone? Hello. I'm waiting for answers. Now I won't go further if you don't answer me on that.
Can you please try to repeat the question, please?
Okay. We have calculated the Pearson and the Pearson coefficient together with the p-value of the wheelbase and the price, okay? So we have calculated, and this is the p-value. The p-value is 8.07 times 10 power negative 20. So are we going to take this wheelbase into price prediction, or we are not going to take this wheelbase as a predictor of price with the results of the p-value?
I think the value is very, very, very small. It's not, I think the value is very small. So on my side, I can't consider it because it is far from the ranges that we have.
Okay, someone's here say that he will not consider this wheelbase as a predictor. Anyone else? Yes, anyone else?
And as the p-value is in the ranges that I'll define above, the value is less than 0.1. So there is a very weak evidence that the correlation is significant.
Okay. Anyone else? Thank you. Anyone else? Okay, hi. Thank you for your contribution. In the p-value, I think we have a lot of We have when p-value is less than 0.001, and then we have p-value is less than 0.05, and then we have p-value is less than 0.1, and then we have p-value is greater than 0.1. So for p-value having 8.07 times 10 power negative 20, that means it is 0.00000000807645648 blah blah blah. Okay, so meaning that the p-value is less than 0.001, and when the p-value is less than 0.001, we say that there is a strong evidence, and meaning that we are going to take this. Okay, so conclusion is that since p-value is less than 0.001, the correlation between the wheelbase and price is statistically significant compared to other. Although the linear relationship, it wasn't extremely strong, as it is 0.58, but it's in the average. Okay, it's almost 58%. Okay, yeah. So the negative 20 here wasn't seen clearly. So this provides that the wheelbase, the correlation between the wheelbase and price, it is statistically, they are statistically significant between each other. Now we have the p-value here. We have the horsepower and the price, and we are having the Pearson coefficient as 0.8, okay, with a p-value of 6.36 times 10 power negative 48. So are we going to take horsepower as one of our predictors? Yes.
Yes, please.
Yeah, we are going to take, thank you, yes. So since the p-value is less than 0 and the correlation between horsepower and the linear relationship is quite strong, 0, so we're going to take horsepower, okay? So we did the same for length and value, and the price, okay? Had a Pearson of 69 and p-value was small. And we did the same for width and price. So these are all the things that we are going to put them in we're going to take them in the model development. Okay, and we have the p-value of, we have the cab weight and the price, where the p-value is negative 53 and the correlation coefficient is 83. So 83%, so we are also going to take this. We also have the engine size and the price, okay. The engine size, the coefficient is 87 and p-value is negative 64. So we're also going to take this as one of our features for model prediction, for the price prediction. And also we have this one, we have a Pearson correlation of 0.5 with p-value of negative 17. So the linear relationship is moderate, as it has 0.5, but the statistical significance is a bit higher, okay, it's less than 0.01. So we can consider it 2. It's not bad. We have also CT mile per gallon with price, coefficient is negative. Negative 0.68, and then the p-value is negative 29. Remember, when we say the linear relationship is negative, we can also take that, okay? So I think we're also going to take this, though the linear relationship is a bit slow, low, but we are going also to take this. The highway also, Pearson correlation coefficient is negative 0.7. P-value is -31. Okay. So we have seen all of this. Okay, so that is Pearson. And now we are going for ANOVA. ANOVA is analysis of variancy. Okay. ANOVA is a statistical method too that you use to test whether there are significant differences between the means of the two or more groups. Okay. And ANOVA returns two parameters. It returns F-test and it returns also p-value. F-test, it shows that it calculates how much the actual means deviate from the assumption, okay? And if there is a larger score, means there is a larger difference between the mean. So if F-test score is large, mean the difference between the mean is large, okay? So they deviate much, okay? And p-value tells how statistical significant is calculated score value is it, as I think the p-value we have already discussed it in here above, okay, in the Pearson, okay. So let's proceed with the drive wheel and let's see how drive wheel deviates from price, let's say, okay. So we want to see. So since ANOVA analyzes the difference between different groups of the same variable, the group by function will come in hand because ANOVA algorithm averages the data automatically. We don't need to take the average beforehand. So let's see if different types can impact price, okay? So here, let's group drive wheels, okay, and price. And then when we say let's group by drive wheels, mean the drive wheel will be the one that will be grouped, okay? We'll have the groups. So here is it, and then we have the rear wheel, we have the front wheel, and then we have the forward wheel. Okay. And then this is the group test, okay? And this is the price, okay? So we can obtain the values of the method. Let's say you want to check between the forward wheel and the price. For forward wheel, which will be the price, okay? So we are having this, we have grouped by. So there are 4 forward wheels in where the price is 17, and there are 1 that's 6 whereby the price is 76. So we can see all of this, okay? So we say we can use FY1 function in order to get the F-test score and get the p-value, okay? So here we're going to take the p-value. So this is the, okay. Okay, so this is the, so we're going to take the F-test value and the p-value, and then we call the statistic, and then the F1 where will result into the F-test, okay? And then after this we are going for, so we put the forward and the price, and then we check on the forward and the price too, but in the time of the rearward and the price, and also get the forward, the front, the forward, and the rear, okay? Yes, so we get the ANOVA to have our F value, and then we have our P value. So the F test is 67, and the P value is 3 times 10⁻⁻23. So we say that this is a great result with a large F-test score showing there is a strong correlation and a p-value of almost 0, implying almost certain statistical significance. So, but does this mean all 3 tested groups are highly correlated? We're not sure. So let's go and check, because this is the one that we group them, all of them, okay? So this is the result of all of the categories, the forward, the front, and the rear wheel. So let's take forward and rear, or rear, okay, rear, okay, the rear wheel, okay. So we take the forward and the rear. How do we get? The F-test is 130, and the p-value is 2 times 10 to the negative 23. And then let's check on the forward and the rear, 2. F-test is 8 and the p-value is 0.004, which I don't think if this is a good sign, right? Remember the standard there, up there, like for p less than 0.001, that is strong. But for p less than 0.1, that is not strong, it's moderate, okay? And then we have the forward and the front. F-test is very small and the p-value also is bad. So the forward, then the front does not have good results. And also the forward and the rear, not much results. So good results are the forward and the, I mean the front, the forward and the rear, moderate results. But the front and the rear have good results compared to all of this grouping. So important variable that we have got so far, for continuous numerical variable, we have length. If you remember, we had good result there. We had length, we had width, we have cab weight, engine size, horsepower, city mile per gallon, highway miles per gallon, wheelbase, and bore. So these are the features that we are going to use them for prediction of the car price. And then for the categorical variables, the one that had excellent results is the drive wheels, if you remember. Yes, so these are the features that we will use them in the prediction of the car price. See? So among all of these features, we got only 8, I think, if I'm not mistaken. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We get only 10 features out of we had how many columns? At first we had we had 29 columns, okay? So out of 29 columns, we've got only 10 columns for the model prediction, and the rest 19 columns I'm not going to use. So this is the importance of explanatory data analysis before model prediction, because it helps you to know what features to use while you are about to have the model, for the development of the model. I can share for you. Currently, I'm doing a research on prediction, as I said before, prediction of viral suppression for adolescents. And there are a lot of features in my data set. I can say I have almost 50 columns. I'm having 50 columns of features. Okay, 50, 60, the range there, 50 plus, okay? And after doing all of these, I just got only 7 features out of all the features that I have always analyzing when it comes out. Among all those features, only 7 features are good, or we say that they are correlated with the prediction of the viral suppression. So this is a very important thing to do, because you cannot you cannot, let's say, create a model or apply a model because some of them algorithms are there. There is mathematical modeling, but most of the models are here. They're just libraries. You just import in Python and then you proceed. So it's a more of a plug and play thing. Okay, we don't write mathematical modeling anymore because all those models have been coded and they are just inside the Python libraries. So you just call them and then you import your data and then everything goes smoothly. So before going there, they say for data scientists to create good algorithms, we spend almost 70% in analyzing our data. Model building is just a one-time thing. Yeah, you just plug and play. But the huge work, it's here in the analysis part where you prepare your data for model development. And I'm telling you, this data is just straightforward. When you go to the field, when you see how raw they are, you have a lot of nulls, a lot of unwanted, a lot of outliers. So the process of cleaning, the process of analyzing is very important before you go to the last stage of the model building. Okay, so I think I don't have much on this. If you have any question, I will go in the chat and answer all these questions. Okay. Someone said, Madam Presenter, how negative relationship differ from demand curve as far as our checkpoints are concerned? Negative relationship differ from demand curve. I don't know if you were speaking on negative relationship in the demand curve or negative relationship in the linear curve. So for the parts of linear, negative relationship means these things are vice versa. Okay, means these things are vice versa. When something is growing up, the other one decreased down. So that is the meaning of negative. In the demand curve per se, I'm not in the cell stuff, let's say, but I think I can say a bit. Demand curve is the curve that deals with cells, okay? The demand, like there is a production, so how much do you produce and what is the demand in the market? Okay, so it's more in the economics. Okay, so it depicts the relationship between the price of a certain, let's say, I don't know, a product, so anything that you can buy, okay? And the quantity of that commodity. Let's say the price is 20,000 and the quantity is 2. Okay, so this one, it's more of, if you have in the demand curve, you have your price and you have your quantity. So if quantity is small, okay, quantity is small and you have a higher price, in the demand curve means this thing won't be demanded much, like you won't get profit out of this. If the demand is high, okay, and you have lower price, whenever the demand is high, it's okay in economics to just increase a bit of the price, but as long as the quantity is high. If you have low quantity, and then let's say if you have a low quantity and then the demand is high, okay, that means you have to increase the quantity a bit so that you can meet your demands, and then the price can also increase. So I think those are in the economic part, which I cannot say that I'm a pro in that area, but I think I know that I'm a pro in these algorithms and machine learning stuffs. Okay, and I think I have give you 1 or 2. And someone say, can we please have the link to the documents that you are using? You can have them. I think I'll share this with Mobile Web Ghana and they will share this to you, but also you can go to Coursera. Coursera have a lot of these courses, okay? Let me do something here. Coursera, they have a lot of these algorithm courses, data science. There's a course that they were providing. It's called Data Science Professional. I did this and yeah, here it is, IBM Data Science Professional Certificate. After you do it, if you're done with this, you can have them. I think I'm putting this in the chart. Okay. So in here, you will learn all the algorithms, you will learn all the analysis part, all of this. And that's at the end of the time, you're going to be given a certificate out of this. Okay, is there any question? Anything that you haven't understood, maybe? I'm all eyes and I'm all ears too. So we can proceed. We could go to the model building, but it's not part of the course and it's a lot of things. I know you're tired of all of this. It's a lot of things, a lot of information bombarded at once. So we'll do that next time. We'll do all the AI algorithms. But for now, I think this is good. And for you to understand this much, what I advise you is do a lot of practice. This is more of mathematics. It's the same as mathematics. If you don't practice, then you don't make perfect out of it. So I'll just encourage you guys to read, to practice, just grab any data that you get in the public. Let's say there are lots of data in the internet. Colab also offer data. There are other websites that you can get a lot of data. So you can just choose pick data and perform this, and then you'll get most of this. Do we have any question? If no question, do we have any question, guys? Suggestions? Okay, Teo said he came late. I mean, I don't know if this is a he or she, I'm sorry. But he said that I came late, but I will follow the page you shared here to learn from there. Thanks. Okay, yeah, you're welcome. Yeah, you will learn more because you have a lot of data science courses. You can learn a lot from there. Okay, Teo. I have a friend called Teofina, and Teo is a she, Teofina is a she. So I think you are Teo something that you call a he. Okay, I'm Theophilus. Okay, nice, Theophilus. Welcome. Okay. Peter, hi Peter. Hi, Peter. I'm glad you're here. I hope this session was something to you, like you learn one or two of the things, because that is the aim. And it's like I understand that you can catch everything in one day. You have to follow up and do a lot of practice. Yeah, thank you so much. Anyone else who wants to talk? Let's refresh now. It has been a long session. A lot of numbers, a lot of coding. Let me write my Instagram account and Twitter account. So in case anyone want to ask me anything. Okay, my Instagram account. For the Suleiman, my Twitter account. And then I have my email. So in case there is anything you want to ask, anything, I will advise, you can just hook me up. Okay, so those are my handles. So guys, I think we can wind this up. Okay, thank you so much for your contribution. Thank you so much for your participation. Have a good evening, all of you. Bye-bye. I'm going to stop sharing my screen and